Okay, well, thank you and welcome. Appreciate everybody joining us today, and thank you very much for taking the poll questions that we had in the beginning. It's pretty neat that the majority of those participating today actually are using Eagle for their work environment. So this is a really good topic. So first of all, let's do some basic introduction. So my name is Edwin Robledo. I'm part of the Autodesk support team. I've been with Autodesk, I've been with Eagle for a very long time. And since the acquisition of Autodesk, I've been part of their support team as well. Everything has gone really well. And there's been some really nice modifications being done to Eagle to improve your design time. Okay. Now, let me just go live with Eagle really quick before he gets here because there was just some aspects of the application that I wanted to share with you before we actually start. Okay. So I'm just going to pause my share really quick. That way I could get that environment up on the screen. In one moment. Okay. So this is the Eagle control panel. This is the first screen that comes up when you actually launch Eagle every time. And what you're going to notice is that if you use the Home tab that's on the top left corner here, on the Home tab, which I'm indicating right up here, hopefully you could see it. It's right there. That Home tab actually lets you preview our latest video tutorials that we've been able to put together for you, as well as the up and coming webinars that we have uh, that you could go ahead and register and participate. What I wanted to show you here is I wanted to take your attention to an area called user language programs. If I expand this, user language program is a C-like language feature that Eagle has, which utilizes a C-like language that allows you to expand the capabilities of Eagle. We have many ULPs already included with Eagle. There's actually quite a bit of them already implemented. You'll notice some of the most common ones are the BOM, creating a bill of materials. Another one is changing values. So if you need to coordinate the values between your schematic and your board, there's a make value consistent between board and schematic. And a lot of these are actually ULPs. To be able to input a DXF file, that is actually a ULP as well. So as you could see, all these ULPs actually extend the capabilities of Eagle. As you could see, they're actually very, very similar to C-like. Once we actually launch Eagle and we go into Eagle, when we launch Eagle, some of these that you see here, these buttons that you see here, they're actually shortcuts that we have created for ULPs, such as also when you do the import button, these are actually, many of these are actually ULPs as well. I just wanted to bring this up because this actually expands the capabilities of Eagle. And the developing team has been using it to implement some tools into Eagle, but users have actually been adding and using the ULPs as well to conform to some necessities that they may need or some compatibility file formats they need to be able to extract from Eagle as well. Okay, so to be able to run a ULP or utilize a ULP, what you're going to be doing is that you're going to click here on the ULP icon. Now, the ULP, you could access your ULPs multiple ways. You're going to be setting up an environment, and to set up the environment or the path where the ULPs are actually acquired, you're going to click here on the Eagle control panel. This is the very first screen that came out that we started earlier today. I'm going to click on options and go to directories. You'll notice that here we have the path here, user language program, which is our default path, which is going to my documents Eagle ULP folder. I actually have another one here, which actually goes to where I have some custom ULPs that generate G-code that I've been practicing with. Also, I have this option ticked, which actually goes to our examples folders where the majority of installed ULPs are going to be located. And I'll show you exactly how this works really quick now. So when I'm going to use a ULP, if I'm going to use a ULP that I don't have a shortcut for it or something like that, if I'm going to use a ULP and I don't have a shortcut for it, when I click on the ULP icon, You notice that I have actually 3 path options. This is our default. This is where all of our default ULPs are located, right here. Okay. I'm sorry, that's not it. This is where all our default ULPs are located. If I'm looking for a particular ULP, I actually can use the search button that we have actually here as well. For example, I could use like the one that we're going to be using today, which is actually using BSDL files. It's actually, I could use BSDL, and you'll see here, there's that ULP, the one that we're going to be using today, which is make symbol device package BSDL file. Now, the other path that I have is our regular path. These are ULPs that I either have downloaded from other sources or ULPs that we have been working on with Eagle, or you have been working on already. Now, this path is actually going, if I bring up my Finder here, this path is going to my documents, to my Eagle documents folder, as you can see here. So if I'm on my path, that way you could see my path a little better here. You'll see my path here. There's my path. So it's going to my users. This is my computer name, Eagle Test, Documents, Eagle, and I have library. So here are the ULP. So every time that you're working on a ULP or you're downloading a ULP, it's best to actually put it in this folder here. As you can see, I've downloaded a lot of ULPs. Yes, because it's just so much easier to use here. Because every time I install Eagle again, because we install Eagle so often, depending on beta versions or new versions. That way, Eagle's always looking for my custom ULPs that I wish to use here. Or you may use one of the ULPs that already come with Eagle, and you may modify it for your own use if necessary. So these ULPs are actually going. And then I actually have one other ULP because I was experimenting. I have a different path, as you could see here. I had a third path, which is this one because I wanted to generate some G codes because I was experimenting with it. So I actually downloaded this from a site and I was just testing it out. So I actually created a path for this one as well. Okay. So that's how you access the different ULPs. And you already have an idea of how to manage it when it comes to your directory structure. I'm going to go ahead and stop sharing my screen and let Jorge go ahead and explain to us exactly what is a BSDL file and how can we use that ULP that we currently have available to our advantage to make high count components. So let me just go ahead and stop my share. That way Jorge could take action. If you have any questions, let's go ahead and leave the questions for the end of the session. If you don't mind, use the chat. You could actually start posting them on the chat if you want to. If you're joining us through our YouTube channel, you're more than welcome. I'll be monitoring the chat on the YouTube channel as well. You could go ahead and post your questions there as well. And I'll go ahead and address them with Jorge at the end of the session. So in the meantime, I'll go ahead and put myself on mute and let Jorge take over.
So check. Can everyone hear me? Let's make sure.
You sound loud and clear, man. Sounds good.
Awesome. So in this webinar, we're going to cover creating high pin count devices using BSDL files. So what we're going to do is I'm going to go ahead and just open up a new library. All of this happens in the library. And the first thing we want to talk about is what is a BSDL file. BSDL stands for Boundary Scan Description Language. And these are files that manufacturers produce. So for example, we go over here. Here, a microchip, I've searched for BSDL and we found the BSDL files that they have. Most of the other manufacturers will do the same. And these are generally only produced for the high pin count components. Sometimes you can find it for something smaller, but in our experience, we've always seen it with the large pin count devices. So once you select, you'll see here that they'll take you to a page where they have all the BSDL files that they've produced or that they have available. As you can see, all of these are for microchip parts as well as some old Atmel parts as well. Or sorry, not old, some existing Atmel parts. And we can use those to be able to make parts in Eagle. Now, what's the advantage to the BSDL file versus, let's say, the package generator? Because the package generator can cover most of, if not all of the footprints that these components use. You know, you have BGA components, high pin count QFPs, QFNs, things like that. Well, the big advantage that the BSDL file has is that it has enough information that Eagle can make the entire device in one go. So it can associate pins to pads all in one go just off of the BSDL file. So you can theoretically, in just this one operation, make the completed device. So it's definitely in your best interest to be able to do that.
Jorge, could I interrupt you just for a minute?
Yep.
I just wanted to explain because I know that everybody here is actually very, very experienced with Eagle, but for those that are not as experienced as we have on our YouTube channel going on right now, I just wanted to let you know that our library editor, when you're creating a component, it consists of three stages. You have your schematic symbol, and then you have your footprint, and then you put it together. We call it like the glue. It's called a device. So you associate a schematic symbol, you create the footprint, and you put it together, and that's called a device. So what Jorge is explaining right now is that when you're using BSDL, importing the BSDL file using the BSDL provided by the manufacturer, it will actually generate all of those parts. It will create the symbol, it will create the footprint, and it will create the device, which is the association of both of them. Eagle does have a tool which actually is IPC compliant plus tag plus a lot more than that that will create footprints. But this stage takes it a little further because it creates the entire component ready to be used on a schematic. I just wanted to bring that up because we do have some friends of ours that are joining us that maybe don't have a good idea of the entire library structure. Thanks, Jorge.
Cool. Good job, Ben. So as you can see, these are the ones provided by Microchip. TI provides their own, so on and so forth. So it's in your best interest, if you know you're going to use a high pin count component, go to the manufacturer's website and just search for BSDL. See if they have it. If they have it, it's going to save you a lot of time, as you will see now when we go into Eagle. So we're going to go into Eagle. This library we've created, we're going to click on the ULP icon. And the one we're interested in is the one that ships with Eagle called Make Symbol Device Package BSDL. Okay, now this is a very powerful ULP. And as you can see, it's very very empty by default. One thing that's good to know for future reference is that this is one of the few ULPs in Eagle that actually ships with the manual. Let me see if this link still works. We'll find it in here in the doc folder. ULP. Oh, because it wants, okay, so that's wrong. If you go to the Eagle control panel, just go help, documentation, ULP, and you'll find it right here. Okay, there's one in German, one in English. And this one is really very very thorough. It covers several examples, how even if you don't have a BSDL file, if you can get certain text from the data sheet, then it can parse it and do some text operations on it to be able to use it for part creation. So very thorough manual. I do encourage you to check it out. As you can see, 33 pages of gold, as the saying goes. But we're not obviously going to go into the detail that the manual can. We're going to go through the most common use case for it.
I
So
thought we were going to read out 33 pages, man.
I know everyone's looking forward to that, but we can't do that in the time we have allotted today. So let's go ahead and get back to the library. So we'll click on ULP. One little trick, if you click any of the ULPs just once and then you press the letter on your keyboard, it'll jump to that area. So it can make it really easy to find. So double click it. Here's the ULP. Now I've already downloaded some BSDL files. I'm going to click on Browse. Okay, these are PIC32MZ BSDL files, EF of the EF family. I'll pick this one right here, this 144. This is the highest pin count they have. Okay, as you can see, Eagle automatically parses it. The ULP reads it in and just breaks it apart. As you can see, it has all the pin names, what pads those go to, the direction for those pads. As you can see, very, very thorough. You'll notice that in this first tab here, we determine what type of symbol we want to use. Generally, it'll guess pretty well, but you can pick other ones. So we're going to leave it with the quad. You notice that it shows kind of a little error because nothing's selected, but or it thinks nothing is selected, but as soon as you click on something, it'll go away. See, we have a symbol name, package name, device name. Now, it's not 100% done. Okay, and the reason for this is that the BSDL file does not contain specifics about the package. So we do need to go to the datasheet for that. So if we go over here, I've already picked a part, which is this one right here. Okay, we're going to go ahead and pick the footprint type that we're interested in. So we go to packaging information. We want the 144 pin package. So we go through 64, 64, 64, 64, 100. We're getting closer. 100, 100. So you can see there are some BGA packages as well. And we're going to make a note about those in a second. 124.
Yeah, we had a question about that in the beginning already.
Yeah.
That was one of the first things they asked if you could do BGAs using this ULP.
You can, but there's going to be a caveat that we're going to go into now in a second. So it's this one. 10 QFP is this one right here. 144, we have our chart. So this is the one we're interested in. Okay, the 144 pin one. Now, one thing that's going to be a little annoying is I'm going to have to jump between the two of them. So I ask you to bear with me. So as you can see, it asks for certain dimensions here. Okay, we're going to use this type of quad package over here. You can see the one with the pin 1 indicator. What we need to do right now is we have to make sure we put in the dimensions. The good thing is that the L and L1 tend to be symmetrical, as do the D and D1, so it shouldn't be too bad. But let's go ahead and go through the exercise. So here we are, D, D1, and in this case it's E and E1. Okay, so let's do this. 18 millimeters and 16 millimeters. Okay, so we'll go back to Eagle, put this in. Whoops. Okay. Now we want to get what that M is, what that dimension there is. So we're going to go again, datasheet. Where are you? Okay, we're not given anything too specific about it because they're all the same. So what we can do, so we're not given that, is for now, I'll just leave it at that value. That'll be good enough for this. Let me see if it shows up anywhere. If anybody sees it, yell it out to Ed. And that way we can correct that. Okay. In the meantime, I'll put in other things like the pin pitch and things like that. So lowercase e, 0.4. Okay, the thickness of the pins. Between 0.13 and 0.23. We'll split that difference, 0.18. Okay, what is W? On W is this, beyond the, so we need that information from the pad. If they don't provide it, then I can just leave it with default values, but let's just take a look to see if they provide that information for the footprint.
Ideally, you have two monitors or you print this out.
Yes. Contact pitch, pad spacing. Yeah, they don't provide any additional information there. So we'll just leave it with those options. Okay. So we'll go back to Eagle. I picked the wrong one. 16 by 16, 20 by 20. I think I got the right one. If I didn't, we'll find out. As you can see, it has all the different options chosen. It has package name. Now, what you have to do is once you put this in, you have to click accept parameter. Whatever you do, you have to click accept parameter on either the package tab or the BGA tab. One of these has to be checked. If you don't, then as soon as you try to make it, Eagle will give you a complaint. Now you have the option that if the package is already existing, then you can go ahead and call it out from here. So use pad name supply with BSDL, pad prefix if existing package is used. You have these options. These last two tabs deal with the manipulation of the text and of the list. Okay. So there's a lot of power here. There's a lot of features that are leveraged, even though the UI is admittedly a little dated, but you can get a lot of things adjusted through here. So keep that in mind. These allow you to do a lot of manipulation with the text. So with that said, we're going to go to make. I'm going to click OK. And there it is. And as you can see, Eagle puts in the right little corner. We have all the pads. I probably put some dimension wrong because I'm noticing that they're overlapping. So I probably did mess up some dimension there. Or actually what it was is we left them the way they were. We left them at the default values. But you can see it gives you a completed footprint. So you definitely do want to check this out. These are the right size, but these are too big. But that's just because I left them at the default values. Okay, obviously you would look in the data sheet and adjust the values properly for the widths and things like that. In fact, I should probably just do it again, just to be extra safe. So that way we don't leave the video with the bad example. Okay, we'll run it again.
So if you notice, there's a little sliver there on the side of the ULP icon that lets you, it keeps track of your history of ULPs that you're running. So that way you don't have to go through the whole list of ULPs again.
Correct. So we're going to go to package. I can leave that alone. This was 18. 18. This was 16, 16. This was the pin width, which I think was 0.4, if I remember. I might be wrong on that. Yeah, I was totally wrong. It was 0.18. The pitch was 0.4. Okay, so now these. Okay, so what we have to determine is, if you notice the Y is super thick relative to the thickness of the pin. So that's part of the issue we were running into before. So let's take a look and see if there's anything in the data sheet that can help us make this determination. The fact that they're a bit long, not really a big deal. So that part's okay. It was really the width that was giving us trouble. So we got to check this Y value. Right now, Y is 0.4. The thickness is about 0.2. And the pin pitch is 0.4. So as you can see, it's really, really tight. So let's see what we get from the data sheet here. Oops, wrong one. Alrighty, here we are. Okay, gives you that spacing, gives you G. So, recommended land pattern. Yeah, so basically they're giving the minimum separation they want between them. So we're gonna have to do a little math to figure out what the what we want that width to be. Okay, of the pad, yeah. Because what we know is we know that between the pads there's 0.4, right? We know that the thickness of the path itself is going to be 0.18. Okay, so what we got to do is we got to just make sure that the separation between them, that space, that gap, is at least 0.2. Okay, so what's going to end up happening is that the width is just going to be very, very slightly bigger than what the thickness of the of the pin is, because in order to leave 0.2 between them, you can have 0.1 on either side, and you already have 0.9 taken up by half of the pad width. So really, the Y value is just supposed to be 0.2, 0.20. So it's just ever so slightly thicker than what the thickness of the pin is. So let me see if I can get a drawing. Let me open up Paint, because I was just talking and I know nobody probably caught the math that I did there. So
I wish sometimes the manufacturer spec sheets had a little bit more.
don't we all? All right. So in advance, I ask forgiveness. I do not draw well, so you're warned. Okay. This is pin number 1. This is pin number 2. Okay. Now, from the data sheet, we know that from center to center, we have 0.4. Okay. That's a 4. We all agree that's a 4. Okay. Now, the data sheet's saying that they want this right here, the space, should be 0.2 minimum.
Take the pitch and divide it by half, and then divide that by half again to get at least half.
Right, so what you can do, let me draw center lines here.
I'm doing construction lines and everything, huh, Jorge?
I said I don't draw good, stop making fun of me. Okay, I think everybody's going to get the idea, though, so that's what's important.
Yeah, Cynthia is saying X1 gives the max the pad width.
Which one? On the data sheet, or?
Yeah. She says X1. Cynthia, is that on the data sheet? X1 gives the max pad width.
Oh, and here I am doing.
Yep, on the data sheet.
Alrighty, let's look. Ah, there it is. Alrighty. Well, there we go.
Thank you, Cynthia. You're the
Thank
best.
you, Cynthia. But there we go. We get the derivation. Basically, you have 0.1 left on either side because it's the center. 0.1 times 2 gives you 0.2, and that was the width that I chose to put in. Okay. But again, you know, had I looked better in the data sheet, wouldn't have had to go through that exercise. So now you go. So again, we accept the parameter. Go to make sure everything is happy. I don't have to click it, by the way. That doesn't matter if that shows up. Say okay.
Much nicer. Wow, that was fast.
Yeah. And what's really awesome is that all of the pin mapping is done. So this part is complete. As you can see, if you go to connect, all the pin mapping is done.
Yeah, the pins have the right name and everything. Now, Jorge, a question to you: does it include do the pins come in with the appropriate property, or they all are all IO or something like that?
No, they get the appropriate directions.
Okay.
So that's another bonus you get with this. So if we go over here, let me pick a power pin. Let's just take a look at the inspector.
Yeah, I see they say passive IO, power. This is right there, AVDD, and they're right there in front of you. Yeah, right there.
Yeah. See?
You got power pins right there. Yeah. Mm-hmm.
So it'll actually recognize whatever the BSDL file contains and will assign that as a direction. So as you can see, super powerful, because really in one go, you've made this component that even for an experienced user would have taken a little bit of time to get done, you know, maybe 15, 20 minutes if you're really able. you know, 15, 20 minutes to make a component gets dropped down to like 5 seconds, you know? So pretty cool. One thing, there was a question about the BGA. So let's discuss the BGA situation. I'm going to go ahead and right click here, make symbol BSDL, go to browse. One thing that's really annoying, at least about Microchip's case with these, and it wasn't always like that, is the way they number the pads doesn't conform to how BGA pads are numbered. So if you notice, here it's just a straight line. Okay? And as we know, for BGAs, you have a mix of an alphanumeric, basically a letter, and a number.
It's like a grid, almost like a grid like type of configuration. A1, A2,
Correct.
A3, and then B1, B2, B3, and so forth.
Correct. So because they didn't do it that way here, if you try to make a BGA off of this one, as it is right now, you're just going to get a big long line. It's just going to be a straight horizontal line because it doesn't follow the naming convention that's expected for a BGA. You see?
Is that only a microchip thing, Jorge, or is
Seems to be only a microchip thing because I've done it with other BGAs and they'd carry the appropriate names with the A,
like
however many.
Xilinx and
Mm-hmm.
the other ones? Okay.
Yeah, so this seems to be something that is unique to Microchip. I don't know what's going on there. I feel like some of the older ones that I used to use didn't have this issue. And those were named properly, but these later ones, these newer ones, for some reason are not. We could try to go into the list and see if we can make an adjustment there, but we don't have any leading zeros. We can try to rename them. So we can go like pad and try to rename them, but that would be, you would have to be a little careful with this because you would have to go into the text string and you would probably have to come up with some really clever rejects to be able to, rejects is a regular expression, to match them and add in the letters where they need to be. And so that would not be too easy to do. You could try to change it over here also in the BSDL file itself, but that's really the key problem here with these. Not all of them have that. In fact, most don't. So in the general sense, you won't run into that issue.
Any chance you have a small example of a BGA with the BSDL? By any chance? Maybe
With
by a different manufacturer?
the appropriate one,
Mm-hmm.
let me check.
Maybe we could download one. Maybe try it out.
I could grab. I know what I could do. Let's see which. Not that one. Let's use the one that we reference as an example. That way we can show it.
There you go.
Hey, where are you?
Just in
TI.
case you just join us, if you click on help in Eagle, you click on help and go to documentation, you're gonna find a document which is called Make Symbol Device Package BSDL. It's in English and in German. That document explains in detail how to use the ULP that we're currently explaining on this webinar.
Okay, where are you? Part name. This one right here. Simulation models, BSDL model. Allow.
That's by TI.
Yep. And I hope they still make this part.
Seems like it wants to download it immediately. Yeah, it's
Here's this one zipped, so I need to extract it. Okay, so now we go over here. Browse. Downloads SPRM. There we are. And you see now the naming convention and the pad naming convention is correct. Is what we would be expecting. Okay, 179 pins parsed. BGA. I just go to the help because they have the that little portion of the data sheet that you need. Symbolic grid array.
And this one, you don't have to bring in the dimensions of the component. You don't have to transfer it. The
No,
data
you
came
do.
in. You
You do.
do?
But
Okay.
that's why I went to the manual, because it already has the BGA set up right here.
Okay.
So I can just copy it off of here. Okay, so we go here, body width 12.1.
So you would just get the values from the specifications, just like we
Correct.
did earlier. It's like we did the first one. Sure.
Pad diameter 0.55. Okay, we accept. Okay. Remember, you always have to accept one or the other, either package or BGA. And if you accept BGA and then you try to accept package, it'll yell at you. Okay. So here we go. We're ready. We're going to use stripes because this has 179 pins. So it's going to be a large symbol. And we're going to click OK. As you can see, it produces the appropriate package. They're footprint. Remember, we can't call them packages anymore. They're footprints.
Footprint, that's right. Now, usually, I mean, this is really neat, but the schematic symbol is fairly large.
Yes, it is.
A lot of times, I've learned some users will actually break the symbol to multiple gates.
Mm-hmm.
That way, they could manipulate the component on different sheets.
Yes.
It's just an option that there is, that if you want to edit the symbol, you could keep the symbol and then copy paste portions of these pins onto different other symbols, break it down to symbols, and then create the device again as a multi-gated element. Is basically what I'm trying to say.
Yeah, and that brings us to a UOP for another webinar, because we can't cover it in this one. But it's one of the other UOPs that has a manual that basically does exactly what Ed just said. So if we go over here to control panel, again, we go into help, documentation, UOP, connect device split symbol. So this one is designed to do exactly what Ed just said. Basically, it'll allow you to split up the super gigantic symbol that was created with 179 pins. You can split it up into smaller symbols for gates, and then make it into a big one and just inherit and make it into a new device and just inherit the connections from the one that the Make BSDL created. So this one works together with the Make BSDL, but that's something for another webinar. In fact, we could probably save this, and the next time we do this one, cover this.
I think that's a great idea. I'll go ahead and schedule that for most probably next month. You'll see that on your Eagle control panel come up.
Mm-hmm.
That way you could work on that. So I think we've covered everything we wanted to cover today, right, Jorge?
That's right.
So, the concept was to take advantage of one of the ULPs that are available in Eagle. That way you could create components that are kind of large. But one of the biggest advantages for me is that it creates the symbol, the symbol, the footprint, as well as the device. That's a really big time saver.
Mm-hmm.
Creating the footprint is a great start. It's maybe the most difficult part of creating a component is the footprint, because you got to take so many things into consideration. That's a big plus with what we have with the generator. But being able to create the entirety of the component on just understanding the ULP. Now, this ULP, just to let you know, you don't only have to run it with
a BSDL.
BSDL files, because I've actually used it in the past without BSDL files. I've just put in the values that I need and I build a part based on, so you don't have to use it. It's just, this was before we had the compliant generator and all that stuff.
Yeah.
This was just one way of actually creating parts kind of easily as well. So you're not, you don't have to force yourself to this. So that document actually explains portions of that as well. So I'll go ahead and open up the platform that way, if in case you have it. Okay. So, okay. I don't see questions here. No questions there. Okay. Well, thank you, everybody. Greatly appreciate it. Jorge, fantastic job. Thank you for the information. Greatly appreciate it. Cynthia, special mentions to Cynthia for for correcting and helping us out creating that part. Everybody have a great day. It's been a pleasure, and see you on the 9th when we host our next webinar. Have a great day. Bye.
Bye, everyone.